in the I guess predictive maintenance around switches and crossings. So just wanted to put a little bit of context around. So this is I guess a continuum that I've evolved since we had it Network Rail, so it's similar, but I think this describes it better than perhaps we did previously in the II program. So I guess the first thing really about data is you need to evaluate what you're actually trying to achieve. So what's the purpose of the data point you're trying to collect, and what's the best way to collect it? So obviously, I think those that know me, massive fan of reliability center maintenance, failure modes, effects, criticality analysis. So we've got some really strong processes in the UK railway that we need to probably use a little bit more. I think they are increasing, but those processes are becoming tried and tested, and I think probably Network Rail probably leads the world in terms of using those techniques in the railway, as opposed to other industries where obviously they've been around a little bit longer. Once you've worked that out, you can then decide what you're going to monitor, what parameters you're going to monitor, how you're going to monitor them, what you're going to monitor them with. Is it a train? Is it by fixing something to the asset? Is it by measuring something on the train from the trackside, so on and so on? Is it from the air even? So there's a lot of different ways of getting that data, and of course there's also the human way as well, which I think sometimes we forget. We ask lots of people to write lots of things down. If we digitize that, then we would get a really rich source of data that we can use more effectively. Once you've got the data, you can then exploit it. So predictive maintenance, bring in algorithms to look for degradation trends, diagnosing failure modes from the data is all becoming much more possible. As I guess computing power progresses, as understanding of algorithms progress, and as artificial intelligence really comes to the fore, which is something I'll talk about later. And then once you've got that, you need to give it to people. So you need to be able to get it to the right person in the right format so that they can use it as part of their day job. And I guess that's where the really strong link to people and culture changes, making it accessible, making it easy, are things that really need to be thought about when presenting data to people if we want them to grab hold of it and run with it. I think in the past we've perhaps been guilty of giving people really nice data sets, really nice information, but they have to log into 5 different places to find it, and therefore they revert back to what they were doing previously because it just becomes too hard for them. So getting that data integrated, aligned, and presented is really key. And then the interaction piece, we need people to use the data, we need people to feed back on the data, to improve the data, to use it when they're out on site so that they are, understand the failure history and don't just repeat what the previous gang did, for example. And then they need to tell us what they did. That's really important. So by understanding what the actual failure mode is, what the root cause was, and what the fix was, or wasn't in some cases, we can then get better, get much better. And it is a continuum. It's got to keep going around the loop, keep iterating, because technology will evolve, and the ability to exploit that data will continue to evolve. And obviously we've got to do this for every single asset that's out there, and there's a lot of different asset types. So this is going to be a very long evolution. I don't think it's a transformation as such. It's part of the day job now, and it'll be part of the day job to keep improving it for the next 10, 15, 20 years. But again, we mustn't forget the people, mustn't forget the culture change, going from what people have done for many years. Lots of people on our railway have been around for 30, 40 years. We need to explain the why, I think, a little bit more about why they should change, what's in it for them, and how it can make their roles better, more fulfilling. And that's a big part of it. And I think every manager in the railway's got a responsibility to do that if we're going to be successful in this area. Moving on to S&C more specifically, this is complicated and difficult, but we need to get on with it as an industry. There's so much opportunity available to us that perhaps just isn't taken because it's seen as too hard or too big. But we need to make, I guess, small incremental changes across all of these areas if we're going to deliver an S&C vision of effective, efficient, reliable, and safe switches, which I think is probably what we all aspire to. There's lots of areas that we need to again iterate, potentially fix, to really achieve a strong vision. So getting the asset data right. If your asset data is not right, how do you know your cyclical tasks are right? If you apply RBM, it's a real paradigm shift in moving from just going out and looking at stuff to actually fixing root cause, fixing it earlier, moving up the P to F curve so that you are maintaining the asset life, really getting to the making the asset last as long as it's designed to, as opposed to the earlier failures that we so often see now. And that's got a strong link to competence. So people who are specifying maintenance need to be competent, need to understand that RBM is different. If you're going to use it, you can't just push your frequencies out and maintain the asset in the same way. It doesn't work like that. So we've got to make sure people are competent and understand what they're doing. But then we need people on the ground to be competent as well. All too often I hear stories of having to call I guess the fourth emergency service, Neil Denton, to come out and measure up S&C for renewal for works delivery. Things like that shouldn't need an expert to be called upon to come and support. We need to be able to give people those skills, and we need to perhaps think about differently about how we give them those skills. Can we codify lots of the things that people like Neil know, get it into an application that's there at your fingertips? I think Neil always uses the analogy about if he wants to fix his car, he looks on YouTube, and pretty sure somebody on there will have a video about telling him what he needs to do. Why can't the railway have that for our front line? Why can't we give them that information so when they're out there, they're able to understand what they're looking at? It's very, very complicated S&C. There's lots of different iterations. It's evolved over many, many years, and each has got slightly different failure modes. Having all that in your head is unlikely unless you are somebody like Neil. So we need to be able to give people a fighting chance to be successful. An output specification, we need to think about how we maintain as well. We can't just keep on doing what we've always done. There's lots of new technologies that some people that aren't necessarily as well embedded as they could be. Things like using Interflon. The results are generally really good if you follow the instructions, which goes back to the training, the competence, but it's still not embedded everywhere, which sort of make you wonder why isn't it? Why haven't, if it really works well in one part of the railway, why can't it work in the next part? What's so different about the infrastructure? And generally the answer is people. So it's how do we get people to understand the best fix and to act upon it? And then in the middle of it all, infrastructure monitoring. So as Andy said, moving away from red zone is a huge shift. It's been done very quickly, and I mean, full respect to everybody involved in making that shift, because it is huge. But if we really want to be successful, then we've got to understand how we most effectively use infrastructure monitoring to drive the predictive analytics, to drive the information that people are given when they're out there, and to drive the ultimate maintenance and asset management regimes. And the benefits of doing this are huge. I am really pleased to see that LR have taken this on and are starting to move forwards with it. But I think there's more that can be done. In terms of all the stuff that's available, there's a phenomenal amount of data out there that we collect, that we store, that we then don't look at, or we do look at, but not as effectively as we can. So plain line pattern recognition, Andy talked about earlier, that captures images of all the switches that it goes over. And because of decisions we made 10 years ago, it gets thrown away. No, that could be a rich source of data. It could help support track moving away from track patrolling, but at the moment it's used only in very small pockets. So there's a massively rich source of data there. At the top, ground penetrating radar. This has been around for probably 15 years. Do we look at it when we've got voiding? I don't think we do. We definitely don't do it everywhere. Again, rich source of data. Why don't we use it as part of the day-to-day job? Why isn't it in Insight saying you've got a twist fault? Here's the GPR. Oh, the GPR, the GPR says the underlying conditions are fine, or you've got an issue, you need to fix it. I'll come back to Connaughts. Then the really exciting project, which I'm really pleased to see moving forward at some really good pace, is the 153, the infrastructure monitoring program. So fitting those downward facing cameras to record the switches and crossings, and not just do the plain line, recording, patting the trains in through the normal and reverse, so you capture every element of the switch. That's phenomenally exciting project, and full credit to One Big Circle, Rail Loc, all the people that are involved in that and making it happen in such short, relatively short period of time. And then in the middle, back to back measurements. I do not understand why we don't use back to back measurements. It just seems like an obvious thing to do. It's not difficult if you follow the procedure, and it gives lots of insight about the switch not being set up correctly. But it's just not used very much at all. There's a big opportunity there, but hopefully the train will be able to do it one day, which is be a fantastic step forward. The Your Rail Scout sim, that's in use in Netherlands, in France. We've looked at it. I think we're bringing it over. Last I heard, we were planning to, but they did this 10 years ago, and Network Rail only just catching up with the train on the left. So get all the things we can learn from that, and can we move faster as an industry? And then in the next row, we've got the points condition monitoring, loads of data there. That's used pretty well, but again, there's more we can do. I'm sure the algorithms can always be improved. And then what do we do when we've got the data? Do we apply products like Interflon, or do we just stick black grease out there? If Interflon's better, why are we still using black grease on switch plates, on slide chairs? Sorry. And again, on the switchblade, some of the results that people are seeing by moving from black grease to product like Interflon are amazing, but it's not everywhere. So why don't we I guess do more about sharing best practice and implementing best practice? And then at the bottom, obviously, track geometry. You've got the Fugro LiDAR surveys, such a rich source of data, generally just used for track renewals. What else could we do with that data if we put our minds to it? You could have a 3D image of the railway in your pocket if we really wanted to. And then again, One Big Circle, the forward-facing video, amazing progress. But it isn't yet all tied together, and that's where I think the opportunity is. And these are some examples. I got sent these today by we're doing a lot of work with Doncaster at the moment, and the ATME is really proud of the progress they've made. So they've moved from black grease to Interflon. They've got a proactive grinding and welding regime, and the impact on the switch defects that they're seeing is absolutely amazing. So I guess it just shows it, when you do get it right and people do put their mind to it and they do apply data and the best techniques they can find, the opportunity is massive. Obviously 2022 is a very small sample of the year, but you can see the pattern over the previous 3 or 4 years. It's such good progress, and he's rightly very proud of what he's achieved. So I thought it was worth sharing. And then the bit for me, really, so Connaughts does a bit of this, but there's so much more that I think the supply chain working together in conjunction with Network Rail can achieve from a switch inspection, monitoring, maintenance perspective, if we're given the opportunity. So Connaughts looks at track bed crossing, usage-based planning, track bed maintenance optimization. That's where we are today. Working with others in the supply chain, we could get to understanding blade health monitoring. The point operating equipment health monitoring is already there, but obviously our two systems are integrated. Heating again, it's pretty well rolled out, but is there more we can do by bringing together what's happening at the track bed, what's happening at the crossing, what's happening at the point machine? Can we get more insight by adding those data sets together and running artificial intelligence algorithms over them to further understand and predict? And then in terms of maintenance, how do we optimize the maintenance? Again, all that data I've talked about, that's all there. That's all things that could be brought together. But at the moment, they just aren't. And it's how can we, I guess, collaborate to really give that holistic switch measurement that ultimately will make the engineer's life easier, simpler, and make the job more fulfilling as well. Both section manager, engineer, and the guys on the front line as well, means that they go out fully armed with what they need to do, with the right tools, with the right equipment, and therefore will get to the right outcome much more frequently. A little bit then about Connacht. So what we do, we've been around for 8 years now. Started out of technical university of Munich. 4 friends decided they wanted to create an artificial intelligence company. I, they then got involved with Deutsche Bahn's Mindbox program, which is like, I guess, a, a, a way that they incentivize small firms to solve their problems. So it's they provide a small amount of money to the company. The company go away and come back with um, potential solutions to the problems that have been identified. So a bit like NetWell's problem statements, I guess, and the R&D program. And then from that, we've built lots of features over the years that go from the monitoring, so measuring the acceleration of the switch, turn that into displacement, with then detected anomalies, ultimately leading to being able to prevent failures, and in the longer term, be able to prescribe maintenance. And one thing that we can do is validate the maintenance, so we can see if an intervention has been effective, if it's given the expected outcome, and we can give that to the engineers. There's a day lag, because you probably work one night, then we've got a day's worth of recording to capture, to understand what has happened, and then we can give those almost real-time results back to the engineers so they can see if they've had the right fix. We provide a user interface. Longer term, we'd look to integrate with NetWell's Insight tool, but initially we do have our own standalone interface. It's accessible from the internet, so you don't need any special software. Ultimately, the AI core is the thing that brings together the information from the switch, alongside lots of ground truth data from the infrastructure owners, alongside hopefully lots of measurements, if we can integrate that data to produce our actionable insights. It's been in the field for 4 years now. We've got around 1,000 devices monitored across 10+ railways. Obviously, being a German company, our biggest customer so far is Deutsche Bahn, and we've now got 850 devices undergoing, I guess, a business case trial. So they've got the product acceptance. It's now about proving the business case in 2 of the German region. I guess there are probably routes. It would be the equivalent. That process has been undertaken this year, and then there'll be a wider rollout across Deutsche Bahn, provided that violation is successful. We got full product acceptance in Network Rail last August. There's 2 methods of fixing the device. For concrete sleepers, we've got an adhesive solution. For timbers, it's a bolted solution. So but we have got product acceptance for both of those. So it obviously depends on the layout, or depend on how we fix the device down. We can go down to 25 miles an hour and up to 215 miles an hour. So a good speed range. Below 25 miles an hour, we tend to see the signature that you get off the trains isn't as good, because obviously the acceleration isn't as high. So that's why we try not to go below 25 miles an hour with our installations. And the operating can operate any temperature that you would see in the UK. The battery life is around 4 to 5 years. We manage that. So with our solution, it's a service. So we look after the device. We make sure it's got up to date software, up to date firmware. So that's all done remotely from Munich. So the only thing that really the maintainers need to worry about is fitting it, and then if the device does fail for whatever reason, we would provide a new device as quickly as we could, and just bolt that back down. So it's a very straightforward fix. The base plate is separate to the unit, so it takes around 5 minutes to change a unit out. It's fully self-contained. It's got a battery in there, as I said, so there's no wiring as well. So the installation design is very, very simple. And it can go on to any S&C. And we do have a unique and mature feature set, which I will hopefully explain. And what one thing about the model that we work with, so we don't sell the devices, we sell the features, I guess. So the device goes into the field, we still own it, and we license it to Network Rail. Is our standard model. Obviously, we'll work with Network Rail on that as we get for more greater rollout. But that does enable us to deliver new features each quarter. One of my big bugbears about something like plain line pattern recognition is that for 8 years we didn't deliver a single new feature. So it was we built it, we got it ashore, we got it signed off, and then it stayed the same. And when there's so much more it could do, and still could do as well. I know there's lots of work now looking at how you can get more out of that data. But for around 8 years, we didn't do anything, which is again an opportunity lost. Going to a service model means that that opportunity is always there. Whereas if you know, but if you buy something off a supplier, you get what you pay for, don't you? So we've, as I said, actionable insights for over 1,000 assets globally, and I just want to go into some of the things that we've found and how that, I guess, matches the UK Railways requirements. So displacement monitoring, I guess, is the first feature. So the device sits there. As the trains go over it, it measures the acceleration of each as each axle crosses over it, and then we it process that data to produce displacement. So we're able to differentiate between where there's an acceleration in the switch, in the crossing or the switch itself, and when the acceleration is occurring in the track bed. So that's quite an important differentiation. But the things so 054 standard, when voiding is identified, record it. How do you record it? You're not allowed to be trackside when the trains are running, or it's very difficult to be trackside when the trains are running. Fitting void meters is practicable, but it's quite hard. You've got to go back twice. You've got to fit them and then go back the following day to take the measurements, and you've got to lift and pack any voids within 7 millimeters. So we've got standards in the railway that are actually quite hard to manage on a practical level, and that's one of the things that Connex can offer. And then similarly, in essence, at the switch as well. So voiding should not exceed 7 millimeters, and where it's modular, the thresholds are much tighter. So how does that work in a practical sense? So here we've got, this is our user interface. You can see we've got quite a significant vertical displacement, so about 5.5 mil. An intervention's happened, probably a tamp, that's lowered the displacement. A further intervention's happened again, and then over time it's starting to go back up, and we can then predict within this, I guess, cone where it's likely to get to within the next 3 months. So within the next 3 months, you've got strong likelihood that you're going to exceed the threshold that's been set by this particular infrastructure owner. We can see that there's a dashboard for all the assets, so you can see which have got a red health status. So red is it exceeds the threshold, amber is it's trending towards the threshold, and green is that it's within threshold and will remain within threshold within 13 weeks. So it enables section managers, so on and so forth, to be able to know where to prioritize their efforts in a nice simple format, and that helps them to optimize maintenance plans as well. So here, predictions, knowing what won't happen. So on the face of it, on the left hand side, this is sort of early days when the assets have gone in. You can see three are already over the threshold, and I think it's 7, but I always get it wrong, could be deemed to be quite close to the threshold. As we get more data, as the days go by, we're then able to see which of those are degrading and which of those is staying static. So obviously the red ones are still red because they haven't been treated. But the one down here, which is probably one of the least obvious ones, is one of the ones that's most likely to go over the threshold within 90 days. Whereas these 5 in the middle are all staying relatively static, and therefore can be deprioritized, I guess. So it helps again making those prioritization decisions. And here's an example we did again. Doncaster DU and Luton DU, where our initial assets were fitted. On the left-hand side, there was plan works, hand tamping planned for this particular switch. The ATME reviewed the Connaught system and made the decision that that wasn't required. So I guess sent the gang somewhere else. So we're doing something more productive. And then at Luton, this is a wooden layout. So we do see a more volatile displacement over time. And I think those troughs are generally, I think, weekends. So obviously slightly lower traffic, potentially lower line speed because of speed restrictions, etc. And we do see quite a difference when speed restrictions are applied. And then this is a really recent one. So this is the last about a month and a bit ago. We identified that we've seen a sudden increase in acceleration. So the displacement is relatively static at around 1.5 millimeters, but the acceleration almost doubled. So we got in contact with the ATME, and this is what we found. So it's quite a key site on the delivery unit. They have previously had big issues with delay minutes caused by voiding, but in this case it was an increased acceleration value, not voiding. Detailed crossing inspection identified that a poor quality weld had left high spots, and show you a video of the. You might not be able to hear that, but you can definitely sort of see that movement as the train goes through the crossing. They've been out again last night to try and grind it, so using a 2-meter straight edge. But actually, what they've found is there's a 21 millimeter squat in there, so they're going to have to replace the crossing. But without our system, it probably would have been found much later. So really sort of encouraging result there, and it comes from working hand in hand with the ATME up at Doncaster, who's been brilliant. Oh, sorry. Show that again. And another example where we've seen crossings starting to fail early. So we've got the acceleration increasing over a period of 6 weeks. In this case, it wasn't being used in anger, I guess, is by the engineers. So they did a cyclical visual inspection, which found a breakout of the crossing on the 20th of October. So you can see right through August right through, increasing acceleration over time. And at this point, this is where they found it and treated it. And then you can see the acceleration's back down to much more normal levels, and a bit of a change in the displacement as well. So if they'd used our system, they would have identified that earlier, and potentially been able to plan it more effectively as well. So again, quite a nice use case there around what the system is able to find. Then maintenance quality. So this is again, it automatically, there's 2 ways that we identify maintenance quality. One is through detecting change. So if something happens at the asset and the change is relatively significant, we're able to identify that and pull out an activity for review by the engineer. So as you can see here, possible tamping detected. That can then be validated, which gives us again a greater source of ground truth. The other way is that the engineers can at the moment manually input any interventions that they've done to the asset, and we would work closely with them to try and make sure that happens. And then longer term, we'd be looking to integrate with Ellipse, so we get a 2-way flow of data, because by bringing that data into our system, we can then improve the identification of defects, so on and so forth, from where our assets are fitted. And you can really understand the outcome of tamping at crossing and switch toes, which is a really nice feature that we've seen some interesting outcomes. So remember that our asset is fitted. In this case, it's at the crossing. In the UK, we've been fitting them at the switch, around the point machine area, the switchblade as well. But in this example, we analysed 100 crossing tamps, and looked at the effectiveness of the maintenance using the infrastructure owner's own measure. So did it reduce vertical displacement by 15%, and did it reduce that vertical displacement below 3 millimeters? So after 3 days, we can see that 75% of those TAMPs didn't achieve that outcome. And then 2 months later, a further 10% had gone back up above the threshold that had been set. So is there an opportunity to do something different when we're putting an S&C tamper through? It's a very expensive piece of equipment to plan. It takes a lot of planning, a lot of logistics. This scarce resource. If we send a gang out with it, can we get a better outcome? Can you get the best possible outcome for the asset? And just some things that we have seen, again, remembering that this is a point measure. It's not looking at SDs, so obviously that's quite a different measure. It's not looking at twist faults, etc.
Unknown participant is now.
So on the first one, increased displacement. So they've gone in, tamped, and lifted it, and the displacement's increased. The next one, did it even need tamping? So 1.5 mil displacement, very, very static, not degrading. So did it need tamping? Next one, not sustainable. So it's gone in. It has achieved the threshold, but immediately it's reverted back above the threshold and then trended back to where it started. And another one, multiple interventions. So gone in. It's been tamped twice, neither of which achieved the threshold that had been set, and the second one again degraded back to where it started within 2 weeks. So not getting the most out of this really expensive resource. And then here is a UK example. So again, Marshgate, so Doncaster, manual tamping didn't really have much effect here, but it did here. But again, it started to trend back upwards. And then here did a tandem tamp and actually increased the displacement. Still quite well within threshold, but it did make quite a difference to the displacement of the asset. Whereas here it was much more effective. So you can see reduce the displacement. What we did find when we discussed it with the ATME, from an SD point of view, it was an increase. It was probably the best SDs they'd had at that location for a very long time. But because it was a design tamp, there was some big lifts in there that weren't necessarily fully consolidated. So again, making sure you get the most out of the money that is being spent is where we can help. Again, just a bit more on the example. So here you can see this one, it has reduced the displacement quite significantly. Most trains are now having less than 3 millimeters displacement, whereas here at the crossing here we've got larger dip angles than we had previously, especially around here, and you can see much more displacement than previously. So not achieving the optimal outcome for the asset. And then crossing health monitor. So this is our newest feature. This takes a little bit of time to bring into fruition as we move to each new customer, because we need to train the algorithms. We need to make sure we've got all the right grounds truth data, age of the asset, failure history, when was the asset, when was the component last changed. But using all that information alongside our device, we're able to start identifying deteriorated crossings. So the various failure modes, being able to bring those out and present those to the section manager and engineers, gives that health state daily. So if something gets worse suddenly, then we would find out very quickly. And at the same time, if we're making an incorrect prediction, it can recalibrate and push the likelihood, the time that it can recalibrate the health score to show that it's actually healthier than we'd initially expected. So it is dynamic in that respect as well. But yeah, one thing that we're really passionate about is getting the right amount of data, and the more data and the more accurate data that we can put into the system, the better the results that we get. And then load-based insights. So obviously Network Rail uses track categories. They're based on net track calculations, which is what does the timetable say is going to be run. I think we all know that the actual traffic against the timetable, they don't necessarily tie together. So using this, we were able to identify the actual tonnage that's going over the asset. Are there any significant changes? And based on that, is our maintenance regime fit for purpose? So are we over inspecting, over maintaining, or under inspecting and under maintaining? So it allows to, in the longer term, will allow us to recalibrate as we roll out across the network. So it gives that real time, real measure of traffic, tonnage, etc. And we did some work with Doncaster again, and found that essentially the network rail EMGTPA equivalent in gross tons per annum is just under 30. But with our system measuring on a daily basis, we established it was probably more likely to be just under 25, which is, I guess, a sort of 16-17% difference. Whether or not that'd make a massive difference to the track category, I think it's just on the cusp of being between 1 and 1A. So whether or not you change anything as a result of that is up for grabs. But just shows the power of having that data and being able to put that across lots of places in the network will enable different decisions to be made about the requirement for maintenance, the requirement for rectification, and the timescales for those. And so where we're going in Network Rail, we've got early stage discussions with Scotland North West and Central. We've got 16 devices in Doncaster, and we've got 8 devices that are going to Whitehall hopefully this month. I think it may push into April now. And then we're in the process of finalising contracts for North and East with 64 devices, 16 with East Coast, and 18 devices for East Midlands. Interestingly, lots of cases, lots of different use cases are being, I guess, requested by the engineers. So in East Midlands, they want to look at before and after refurbishment sites. For North and East, it's all about proving the business case. So what difference is it going to make to maintenance regimes? What difference is it going to make to change out of key components? Whitehall is all about monitoring how successful a reballast and changing the bearers was. A key junction, so is where the freight crosses over with the passenger traffic. And then East Coast, looking at where they're seeing significant crossing wear, so they're having failures within 2.5 years of the S&C, the complete S&C renewal. So it's how can they understand what's happening more at the asset and then act differently. And then 18 devices for Western Route, very similar to East Coast, looking at high-speed crossings. They get seen a lot of early failures in their high-speed crossings and in some of their turnouts as well. So we're working closely with Dan Collins to pick the best locations to try to pilot it on Western. And then we have put an offer into Wessex as well, which has been evaluated at the moment. So we're starting to get lots of pockets of rollout, and I guess the next stage really is trying to get a tender out of Network Rail so we can move from lots of small work to something more strategic, if that's what Network Rail want to do. And then the last bit, really getting the integration strategy. As I said at the start, the last thing probably a maintenance engineer wants is another login to remember or another screen that they've got to dig around in. So if we're able to work closely with the Intelligent Infrastructure Programme to integrate our data into the Insight tool, then we think that'll help adoption, but also help build that holistic picture of the switch. But at the same time, we do think our UI, our user interface, will continue to need to evolve and stand alone, because we will bring in new features. For Network Rail to take those features on, they're going to have to rebuild their system. So I think there'll be some features that are replicated in Insight, and then some of the other features, the newer features, as we develop them, will still sit in our UI. But having a sort of straight link through from Insight is where we want to get to, if we can make that work. And the other thing really is we have customer success managers and solution engineers. The customer success manager is all about running the project, running the install, but then making sure that the engineers understand what the data is telling them, having regular updates, looking for insights that people might not otherwise see because they've got busy day jobs, and then bringing that to the attention of the engineers and section managers. And then the solution engineers are experts in S&C, so we deliberately recruiting people with strong background in S&C to support us. We've got Neil Denton supporting us as well on a more ad hoc basis, providing his insights. So really trying to get the best of breed of S&C engineer into supporting our system. And then this is the benefits case that Network Rail and Eastern came up with. So anticipating being able to reduce delay minutes by 20% and get 25% crossing and half set life extension. Sometimes obviously that's very short at the moment. And ultimately, can we push the lifetime of the S&C out beyond where it is today by up to 25%? And then the final piece that we need to do more work on is we've got all the we understand all the maintenance that is done. What we don't yet understand is once Connex is more embedded, what impact that would have on an overall maintenance regime. I think I'll finish there if that's okay. Hopefully that was useful.
Thank you very much indeed, Tim. That was fascinating. And are you okay to do some Q&A?
Absolutely. Yeah, that's what. Yeah, I know. I want for. Yes, I'm here as long as you want me.
Fantastic. So, yes, if you would like to ask Tim a question, please raise your hand in the Zoom app, and I'll invite you to come off mute and ask your question. And I see that Paul Meads has got his hand up. So, Paul, would you like to ask your question?
I thought it was only fair to get him first, really. Thank you, Tim. And in particular, it's really interesting to see the insight in terms of how we can improve the management of our crossings, because it really is the greatest probably business challenge that we face at the moment, certainly on Southern region currently. I was really interested and kind of nodded wisely when you were saying about the importance is to change the culture and get people to use this insight that's provided to them, and that's one of the challenges. With the exception of shutting the stable door after the horse has bolted, because people tend to react well to failures. I was wondering if you had any particular successes in mind where people had converted to this that we could take forward as a lesson to use for the future to get people to embrace it.
Yeah, I mean, I think it is still quite early days in Network Rail, but I think some of the things that Josh at Doncaster is so. Basically, we look for the insight, and if we see something change, we give Josh a ring, and he goes out and deals with it. So that crossing that you probably couldn't hear because I forgot to press share sound, but it's making a hell of a rattle through there. They wouldn't have known about that if we hadn't found it until obviously they were out for inspection, and then if they're not inspecting under load, would they ever have known about it? So we found 2 squats. One was 2 mil or whatever, but the other one they kept digging in. 21 mil squat. So if that got much further, you end up with a speed, I guess. I think 25 mil you probably got to put speed in, have you? Is that right?
I think so. I can't remember the details myself, but I guess that's about the case of making it relevant to them and make it relevant and immediately linking to a benefit. I kind of guess is a key.
Yeah. And then the stuff at Marshgate, the TAM was really interesting. So we were like, it's got worse. And Josh was, it's got better, because the SDs had improved, but you can see the sort of, it's taken out lots of dip angles, but those sort of key locations at the switch and the crossing, the displacement, I think 5 out of 8, the displacement had actually increased because it was a big lift. I think it was a 38 mil lift at some point, so it was a big lift, but obviously that's just going to revert back, isn't it? If you leave the displacement in there, it's just going to degrade over quite quickly. So and they do follow up, and that's been really refreshing, getting the right people who want to I guess make a difference. And those graphs on the switchblade as well, that's all from Josh. He sent me that this morning. I just thought it was a really good example of when you put your mind to it and apply the best techniques that you can see some brilliant results.
Yeah. Thank you, Tim. Thank you.
Thanks very much. Joel Bates, you've got a question for Tim. Would you like to come off mute?
Yeah. Okay. So firstly, congratulations, Tim. I was playing in this space probably over 20 years ago, at a time when generally people weren't digitally literate. We couldn't process data. And also congratulations for you to getting type approval from Network Rail, because that's a bit of an achievement. I suppose what there's a number of things I'm interested in is firstly scaling up. So what you've shown as the deployment for the UK, I guess, is on the critical switch ends, the sort of in the parts of a quarter century ago golden assets. And although we've now got measurements and then the analytics, and then we've got eager beavers like the TME at Doncaster, to what extent are we still trying to design out the problem? Because I was involved with HS1 in its early days, and what struck me was that here was a proven French design that worked straight out of the box, was heavily engineered and quite expensive, but in the critical locations, it's kind of affordable. And you know, things like better steels, better bolts and fixings, switch rollers. Talked about better lubricant. Is that still part of the play? I mean, God knows the HPSS point machines, when they were introduced that time ago, were a bit of a breech birth. Hopefully they've settled down. But you know, I applaud what you're doing and changing the mindset. But can we engineer out the problems to a greater extent, or have we optimised that?
I think sometimes we forget. So I think a lot of work's gone into getting the S&C right for the future, and I think some of the newer types of S&C are much better designed. But we quite often forget that there's 20,000 assets out there, and we change how many a year. So there's loads of good things that can be done to improve the current asset base, and how well is that rolled out? Things, you know, things like moving to rollers, using the newer way of fitting the rollers so it's fitted to the rail as opposed to the base plate, so it can't move. All those things, integrated sole plates, all that sort of stuff that's been designed and people have put a lot of effort into. I just don't think enough people know about the opportunity that they've got. So yeah, I take your point about bringing in the best of breed, and I know a lot of work's gone into that, but if you just always looking at the future and don't look at your legacy assets and what we can do to fix them, we've got problems for many years, haven't we, until we get to the new asset. So I think sometimes we need to look at how we can make those incremental improvements on the existing asset base without moving to something radically different. Because if you bring something different and you've got all different measurements, so the back drive settings on the new S&C is different to the old ones, so somebody's got to remember that. So that's another challenge, isn't it? So how do we make sure people are competent in when we bring in new assets? I don't know if that answered your question, but
yeah, partly. And if you look at the back drives on a long switch on HS1, there's only 2 or 3 people allowed to touch them because it's like tuning a piano. The other thing is, I applaud your tackling the sacred cow of tamper quality. I mean, I don't know how much they cost these days, £2.5 million. We've got highly trained crews. They go in there and achieve nothing, is what you've just shown us in. And think of the economics of that in terms of track access, let alone the cost of running it. If we can just turn the dial and get it from 25% to 50%, the weakest part of the track infrastructure gets progressively better for just being a little bit smarter with the quality of what we're doing.
Yeah, no, so, absolutely. Spending a few more pounds on it.
For Network Rail on this call, I think that's a red flag to me. That's a lot of money going down the toilet. All that effort and track access. Yeah. Anyway, well done, Tim.
Yeah, no, great. Graham Penfold's looking at trying to modernise it a bit and trying to get much more effort out. So hopefully it's successful there, and that can get rolled out across the network as well.
Thanks, Joel. Great stuff. Dave, I'm slightly worried about the money going down the toilet thing, and that is a really good challenge. A really good challenge coming out of the data, and it prompts a question for me later on. Dave Merritt, would you like to ask your question?
Yeah, it sort of partly links to the previous one. I mean, how much does this data help to identify design defects as opposed to simply deterioration? Can it be used at all in that way?
Was potentially. I mean, we're looking at some things, particularly around, I guess, the switch and I guess when you've got. I was talking to Brian Whitley about this last week, but if you've got a 125-mile-an-hour running line and a 30-mile-an-hour turnout, we design for the 30-mile-an-hour turnout, not the 125-mile-an-hour crossing. So, funnily enough, the crossing gets battered. So things like that, we think it will be able to identify, if that answers the question. The switch element is much less developed. We can see where we've got lots of vibration, which can hammer the point machine, so on and so forth. But I think there's quite a lot that we can see, and picking up lateral movement in the switch, so seeing a lateral force going through. But that's sort of a future feature as opposed to something that we've got fully implemented today.
Thank you.
Thanks very much, Dave. Just an encouragement to people who are at the meeting. If you want to ask a question, you've got unique access here to a real leading light. So please raise your hand and ask your question. Tim, in the meantime, if I may. So one of the things that we're looking to do, obviously, is reduce track access, and the system that you've described gives us the potential to reduce the amount of track access for monitoring. It leads to a requirement to inspect, though. So do you imagine that part of your system, or the way that it's implemented, needs to grow so that the inspection becomes part of the automated process as well? So, for example, on that, the one that you told us about with the crossing there, do you imagine that in the future we'll be able to look at images rather than go to look at the track to find out that? And is that where we need to head?
I completely believe it, Andy. You'll remember we tried and did the S&C project many years ago, and we didn't pull it off because we couldn't find cracks in stretcher bars, which I'm still don't think. I think we could have done something different, but anyway. But yeah, the infrastructure monitoring program is the class 153. There's sort of a little picture of it. I think that's probably the future of switch and crossing inspection. And if we can get lasers on there, or get lasers from another source such as the Fugro system, bringing all that data together should mean that you only ever send people out to do work, not to necessarily inspect. Things like dye penetration test, obviously you can't do that from a trainer automatically, but there's definitely the potential, again, alongside risk-based maintenance as well. I know I talk about it a lot, but if you go to Swindon, you go to Bristol, they've fully implemented risk-based maintenance. It can't be that different there to other locations. So, and they've turned it around and done it, and it works for them, and they see asset improvement. So that's, if you have risk-based maintenance, you need to send the train out less often, which makes the train affordable and means that you can make that step change away from boots on ballast. So I think all those things coming together, that the holistic switch is where I see the future. So having the video, having the geometry, but the switch in both directions, having laser scan of the switch, getting that back-to-back measurement, they're all pieces of a holistic switch puzzle that are not a million miles away. You've gone on mute, Andy. I can see you talking.
Thank you very much. They're all included in the price. And Paul Meads, you'd like to ask a question?
Yep, me again, I'm afraid, Tim. I'm just curious whether you've looked at or have any plans to look at the effects on in terms of modular bearer layouts, either in terms of whether there's any indications that you can get in terms of the need to intervene on the modular bearer assembly and to service that, or perhaps the effects that the modular bearer layout is having on the performance of the crossing?
Yeah, so it's a source of interest for us, definitely. Mark Rowlands on the East Coast has done some work with Southampton and Leeds unis, is that a word? Anyway, universities to fully instrument up Tallington, I think it is, and they're currently just getting the report for that at the moment. But we are putting our system into Tallington, so it'll be interesting to see what we see versus something that's much more complex that wouldn't necessarily you couldn't roll out that sort of system everywhere on the network because somebody had knocked the sensors off. That it was a temporary installation as opposed to a permanent installation. But it'd be really interesting to see how we compare to that.
Yeah.
And I was talking to Roy Hickman about modular bearers last week. So if you're having massive problems with some of the early ones, he's got some ideas about why. Not necessarily fix them though. He might just tell you why.
No, fair enough. Thank you.
But yeah, I think we're doing St Neots, Tallington, and somewhere else on the East Coast for the modular bearers.
Thanks.
Thanks very much, Paul. One more encouragement to guests. If you would like to ask a question, please raise your hand. Just one more from me, if I may, Tim. So do you think there's room in what you're doing for, at a particular S&C layout, one of your big boxes that has the capability to do everything, with a little family of simple boxes that just has much more specific and therefore cheaper functionality with it? So, for example, you might put your big box next to the crossing, and then put some little boxes on the on key modular bearers, for example, just to monitor vertical displacement and nothing else. Is that something that's worth considering, or do you see it as a one size fits all box that goes everywhere?
No, it's a really good point. So in Germany, we are putting a wired sensor that runs from our box to the switchblade. So it's similar idea, different use case. So I think that is definitely potential for that in the future. Without a doubt, yeah. I mean, our system isn't going to do all those things I described. What I think where I see it is the supply chain that we're all working out how you get to that position, and then bringing it all together so that it's all the information you need is in one place. That's really key. But yeah, there's definitely potential to develop further. The issue with anything when it comes to monitoring is making sure that it's size 11 boot proof, I guess. So I guess one of the reasons our box is so big is so that if you do kick it, you'll hurt your foot and you won't break it.
Very good. Okay, there are no further questions. So if I may, I'll draw the session to a close. So thank you very much indeed, Tim, for a really splendid talk and really well illustrated, if you don't mind saying. So with plenty of stuff to excite our engineering interest. So it wasn't just the theory of what you're talking about. It was also the practice, which was some great insights there. And we haven't had too many questions on it, but thanks very much for emphasising the importance of people and culture in your talk in terms of really taking this sort of thing forwards, and emphasising how it's not just a whizzy box and a solution, it's the hearts and minds of the people who are going to use it, their motivation to use it, and the culture of the company in encouraging that. So thanks for making that point too. I hope you've enjoyed presenting to us this evening. You've prompted some great questions. I particularly like the one from Joel, and I'd love to talk to Joel about that when we reconvene face to face come the autumn, hopefully. But thanks for an excellent presentation, and on the call. If you'd like to come off mute and applaud Tim for his applaud Tim for his talk, I think that'd be really great. Thank you very much, Tim.
Thank you for having me. Really enjoyable. Thank you. Great questions.